an hour ago. Okay. So they're ready to go for it. And breathe. Okay. So we want to find the velocity at time t. This is part of what Viv and Bree can learn right now. What do we do to find the velocity? Take the derivative. What rule would we use to find that derivative? The quotient rule. And so I have v of t is equal to, what is the derivative of the top? 4 times the bottom, which is t squared plus 3, minus the derivative of the bottom. 2t times? Great. So you're becoming very efficient at taking your derivatives, which is something that we want to really have that skill. I'm going to distribute my 4, and I get a 4t squared.
Yes.
Did I make a mistake?
The bottom should be squared.
Oh, thank you. And then 4 times 3 is 12. Then I have a minus 8t squared. And then I have a plus 20t. All over that t squared plus 3 quantity squared. Or in other words, a negative 4t squared plus 20t plus 12. All over t squared plus 3 that quantity squared. I wrote it here because this is where I'm going to graph my derivative. Because you really get to use your calculator basically the rest of the way. We want you to be capable of using a calculator in this fashion, so please go ahead, take it out. And do not type in the position, or yeah, let's type in both. We'll put the position function in y1, and we'll put the velocity function in y sub 2. I did not hit a raccoon this morning.
That's a joke. Sounds like something somebody who hit a raccoon would say, honestly.
You would know if you were here.
Right.
Is it a plus 20t?
Yeah.
And then plus 12?
Yeah.
Another 30 seconds to get that typed in. And what I would like to do is I'm not going to highlight the first one. I'm just going to highlight the second one to just see the second graph. I think I have a general idea what this graph looks like. I'm going to zoom standard. Remember, we're only talking about from time 0 on to infinity. I'm going to zoom as a decimal. That tends to get me a smaller viewing window rather quickly. Okay. Everybody see that? All right. Press the trace button, because part of what we're interested in is the velocity right now. Is the velocity positive or negative? Positive. Right now, is the velocity positive or negative? Positive, because this is the velocity function, isn't it? Okay, so it's the velocity is positive when it's above the x-axis. So am I traveling to the left or the right? Traveling to the right. And I'm still traveling to the right, but maybe at some point I travel to the left. What would happen to the y value if I'm traveling to the left? Let's see if we see it turn to negative within this window. And it does turn negative somewhere in there, doesn't it? Yeah, it does. Okay. So if you wanted to, we could change our window a little bit, but it looks like I can get a negative reading. So it looks like it does cross over to negative somewhere around a value of like 5 or so. Okay. So I'm just going to try to draw that sketch for my graph so we can make sense of it. That is the approximate graph of my derivative. Let us answer these questions and try to use our calculator to answer them. It says, what is the velocity after 3 seconds? How will I compute that? Plug in 3. If we simply go to our calculator and we go to table, and we type in 3, you will say that y sub 2 is 0.25. I saw the hand go up. That was just remotioning the shirt. Got it. Okay. 0.25. So where are we here? So we have velocity after 3 seconds, v of 3 is equal 0.25, and our measurement is going to be in feet per second. We all know how to use our table in order to compute that. We're good?
Yeah.
When is the particle at rest? That's when the velocity is equal to 0. And we said it's equal to 0 right about there. We're going to find that spot by using our graphing calculator technology. Anybody know what I'm going to press? 0. Go to that number 2. I need to go to the left bound, so I'm going to look for a positive value. So notice here that the y values are positive. I press enter. And then I'm going to my right bound. I need to cross over so that the values are negative. And they are negative there. I get 5.541. We could have used our calculator, done it by hand. It would have been a lot more work. When is the particle moving in the positive direction? Have that 20-second conversation with the person next to you, see if you can identify when's it headed in the positive direction. Go.
0 to 5.5.
Okay, we're looking when the velocity function is positive, and the velocity function is positive from 0 to that 5.541. On the answer key, I was a little bit more critical about when we would have a bracket and a parenthesis. You can put parentheses on all of these and it's fine, okay?
But you don't care.
I don't care. And now we get to our last part, find the total distance traveled during the first 8 seconds. This is the part that's a little bit more complicated. And remember, when we're talking about total distance traveled, we need to consider the start. What else do we need to consider? The change and the end. So that happens at specific times, and I'm also then looking for specific places where that happens. And my original function is 4t minus 10 over t squared plus 3. That's my position function. At what time do I start? 0. At what time did I change direction? 5.541. We will always go to 3 decimal places when we use our calculator in these situations. And what time do we end? 8 seconds. Now, I want to know the location. So, Bree and Viv, this is the important part. This function tells us location. This function tells us velocity, okay? There's a big difference. So we've used our velocity function to answer a lot of these questions. When it's talking about position, we need to come back to this one right there. So I'm going to go back into my calculator, and I am going to go into y equals. I'm now going to highlight y1. So it will now produce values for me for position. And if I go to my table, notice it's putting out y1 and y2. We're not concerned about y2 right now. That's the velocity. But we plug in 0, plug in 5.541, and we plug in 8. And again, everything we get under y1 is our position. So we start at negative 3.333. And then the change was where? Yeah, what was my location?
0.361.
361?
Yeah.
Thank you. And then the end was 0.328. So I'll diagram this motion now. You don't have to write the times underneath. I just do that to try to help us out to understand the order. So I start at negative 3.3 repeating, and I head on over to the 0.361, because you guys said I start by traveling to the right. And then after that, I travel to the left. That's the motion of my particle. So if we want to find the entire distance is going to be this. And so I tried to make a point with the other class yesterday that if you're looking at distance, it's always right minus left. So we have two distances. Our first distance is 0.361 minus a negative 3.333. We're going to get that. We're going to add that to our second distance, which is 0.361 minus 0.328. So if you're ever wondering how to calculate a distance, it's always your right minus your left, okay? And so I'm going to do those on my calculator. Parentheses, 0.361 minus a negative 3.333. And then I add that to 0.361, and that's minus 0.328. Did I get that incorrectly? I'm sorry, did I type that in correctly? Incorrectly. Look at that. 3.727. Very typical of an AP exam question. In fact, if at your other classes you look at, anybody seen a free response question from, say, an AP bio exam or a AP psychology exam or something like that? This would be the foundational, most common problem asked on a free response question. But this would just be basically two parts of, say, the 4 parts of that question. So it definitely extends further, but this is a higher level application. So take out your homework so we can talk about kind of your goal and where you want to be. Did you swim meet last night? How'd it go?
It went really well.
Good. How'd you get all this done?
I did that before the meeting.
Wow. Okay. Good for you. So here we got all problems 1 through 4 done, and I think the answer key's posted, right? You checked them and you're all good? Good. You can feel really confident moving forward because this is the application piece. After this, we're talking about taking derivatives the rest of the way. So we have different derivatives we're going to look at. For example, the derivative of sine is cosine. Derivative of e to the x is e to the x. Derivative of natural log of x is 1 over x. We're going to do those, but we're going to find derivatives. You're going to get your driver's license so long as you all pass, okay? So the bottom two, numbers 5 and 6, my intention is that you would use your calculator on those. Now, you don't have to. You can technically do them by hand, but my intention is that you would take them through kind of like we did on your calculator. So don't feel bad if you come up with some nasty numbers. I mean, honestly, you guys, the first 4 problems, you get some really nice integers, don't you? Yeah. So, now you kind of deal with some decimals. Okay. That makes sense? So if you are, if you have those first, if you've got, like 2 or 3 of the first problems done, and then 1 of the calculator problems done by Monday, you're probably saying good situation. You just don't want to be here on Monday when we're moving on to stuff and say like, okay, I still have no idea how to do the motion stuff. You don't want to be there. You want to have your questions ready to go. And you don't want to be putting this off until the test, without a doubt. So, okay. I'm going to stop this. You guys